We're going to show you in this video how to take an NMR spectrum of your liquid unknown. You'll need a few things to accomplish this. One is the unknown. The second is the NMR tube. That's found in your locker, and it's a thin glass tube with a top. You'll also need a clean pipette and a bulb, and access to a bottle of deuterochloroform, which is found in the hood. It's important to read the label before you use it. It needs to say chloroform D. It also contains TMS as the standard set to 0. One thing you want to pay attention to is your NMR tube needs to be clean and dry before you do this. It's a good practice to clean it with acetone the lab period before you use it and leave it open in your locker to dry. First, you'll put the liquid sample into the NMR tube. So take the cap off the top of it, and you'll put in about 1.5 centimeters height-wise of the liquid. The total sample is going to be about 4 centimeters, and about 1/3 of that should be your sample. Then you're going to add deuterochloroform slowly and carefully to get to a total height of about 4 centimeters in the tube. You might want to use a ruler the first time you do this. After a while, you'll get pretty good at it and you can just eyeball it. A good rule of thumb is 3 fingers. That height is about the right height. Then you cap the tube and you're ready to go into the instrument room. This is the NMR room, and you're looking right now at the magnet, which is where your sample will go. There will probably be a sample already in there, and so you'll have to eject it first. There's a button for the ejection and the injection, and you'll hit eject, and then it will pop out of that lighted tube. You'll lift it out, and then take off the spinner. Take your tube and then put the spinner on. You put the spinner on the bottom, and then you put the tube into the depth finder and you push down until it stops. Then put the tube into the lighted hole right there, and it will bounce around on air and then hit inject. And it disappears into the magnet. Theoretically. Now you head over to the computer screen. You need to open the program to get the spectrum. It's called AII. It's on the desktop. Just double click. It will open a screen that's white like this. You only have to change one parameter, and that is the number of scans. It defaults to 1, and you're going to want to have it read 4. So you type in NS and then enter, and change the number of scans to 4, and then hit OK. Now you're ready to actually gather the spectrum, so you type ZG and then enter. Then just hit save, and it will save it to a general data area. The little green box in the corner tells you that it's running ZG, and it's going to show an NMR FID on the screen. You want to not do anything until that green box goes away, signifying that it's done taking its scans. You can see the scans counting down on the screen. Right now it's 2 of 4. And then it should change when it's done to 3 of 4. When it goes 4 of 4, that green box will go away. Okay, it's got its 4 scans. Now we need to go to a different program called NUTS to actually turn this into a workable NMR spectrum. You can find that program pinned along the bottom, it actually says NMR. Click on that. A window shows up, just hit OK. Now we need to transfer the data over to this program. Hit Control F1. This window pops up, just hit cancel. There's our NMR spectrum, and you can see that it has some peak labels on it. They're at the top of the peaks. They tell you the chemical shift or parts per million value. And you can also see some integrations. We have some adjusting to do though, so we're going to walk you through that. The first thing you'll want to pay attention to and verify is that TMS is set to 0, which it always should be. So come to the furthest right-hand peak, locate TMS. We see that it's at 0, so we're fine. If it's not, the directions lead you through a few short commands to change that scale and shift it to 0. You want to do that first. In the instructions, the next thing it asks you to do is to label the peaks. You can see that they're already labeled. Those numbers are along the top. And so we're not actually going to do that since it's already done. But if you ever needed to, you could follow through those instructions. So we're going to jump down to doing the integrations. This one is integrated fairly well, we just have to adjust the numbers. You can see that each peak has its own broken integral associated with it. However, sometimes the instrument misses a peak, and so you need to know how to do the integrals on your own so that you make sure that every peak gets integrated. So let's say this is what the machine spits out. The first thing you're going to want to do is enter integration mode by typing in ID. Don't hit enter in this program because it will kick you out of the integration mode. Now we're going to clear the computer set integrations by typing in C. Now what we have to do is take and section off each peak on our own. You'll take your cursor and go to the left side of the peak you're interested in, click it one time, and you get a vertical line. Click on one side of the peak, click on the other, and that peak is now sectioned off. Go to the next one, click one time to get the cursor, click one side, and then the other. And then do it for your third peak. One side, and then the other. So now we've sectioned off all the peaks. And if the computer were to miss one, this is how you would get it back. There are numbers assigned to the peaks, but a lot of times they don't make any sense initially, and so you're going to want to actually make them some whole numbers. So there are a few ways to approach this. You can, if you know what the sample is, actually put in a number and for a known peak, and everything else should match up. If it's your unknown, pick the smallest peak, call it 1, see what else the other numbers look like, and then scale up as necessary. We know what this sample is, and the triplet at about 1 parts per million corresponds to 3 hydrogens. So we're going to show you how to set the number. What you'll want to do is go and point right at the integral line and click one time. Type V for value, and a window pops up. And it says current value is 1.6. We know it's 3, so we're going to type in a 3, and then hit OK. Now if you didn't know what it was, you might type in a 1 and see what that does, then change it, type in a 2, see what that does, until you get close to whole numbers. You can see now it labeled that triplet with a 3, and it labeled the quartet a little more downfield as 1.84, which rounds to 2, which it should be, that's an ethyl group. And then we have a monosubstituted benzene, which should integrate to 5, 4.85, that's 5. At this point in time, when you're happy with your integrals, you want to hit enter, and then go to the menu under File, and hit print. And it's a good idea to change it to landscape so it's stretched out. Then hit OK. And there's a printer in the room, and it should print right next to you. So you can go ahead and take a look at it. And once you're happy with how it looks, you're good. Once you're done and you're satisfied that it printed and looks good, it's time to eject the sample. Open up the lid, come over to the button that says eject, hit it, and your sample pops out. You can take it out and make sure you leave the spinner in the room when you leave. Don't run off with it. At this point, you're ready to go back, dump the contents of the tube in the waste, clean your tube with acetone, and leave it open to dry for the next NMR.